Good evening, everyone. It is once again Ted the Speed Learner, and tonight I'm going to do an update on a video I did over a decade ago. It was a video that had ISA, PCI, and LPC bus, okay? And I already updated the ISA, and tonight we're going to update the PCI, and then the next time we're going to update the low pin count. Now, any mistakes that I make in this particular video, I'm going to include the correct information in the next video, which will be the low pin count bus, okay? But this video series is not only to replace the original video I did a decade ago, but it's to upgrade it as well, and there will be actually more videos in that series than what I thought there was only going to be 3. There's actually going to be about 5 or 6. So, it's like, whoa, we're not done yet. Not even close. Okay, the first thing you need to know about the PCI bus is what the letters of the acronym stand for. The letters stand for Peripheral Component Interface. Now, if you'll remember from the ISA bus video, I actually went through the etymology of the word peripheral. Okay? So, who created the PCI bus, and when was this technology created? It was introduced to the computer world by the Intel Corporation in 1992. Why was this technology introduced? Do you recall when I discussed the term megahertz and CPU clock speeds in my ISA bus video? If you don't, go back to that video, watch it, then come back here. Now, CPU speeds steadily increased. But before I discuss this further, I need to introduce you to a man by the name of Gordon Moore. Ever heard of him? He was the co-founder of the Intel Corporation. He created a law called Moore's Law. He stated that the number of transistors on a microchip should double every 2 years. Why is this law so important? Well, one of the reasons Moore's Law is so important is that the ISA bus boards simply could not keep up with the number of transistors that were being attached to the more modern day CPUs. So the Intel Corporation created PCI bus cards. These cards were able to send 32 bits of data, or 4 bytes of data, or 4 alphanumeric characters to the CPU at a speed of 33 megahertz a second. Now, from what I understood, and I really tried to do my best research on this, and I may not still be clear on this, well, what you do is you have this highway, and this highway in the original ISA boards was just divided in half, so you had 2 lanes, okay? So what would happen is that you would have 8 bits on one lane and 8 bits on another lane, and they'd be set off at the exact same time, and they would travel down the whole lane of the road at 33 megahertz. Okay? So, when they're talking about sending a data packet of 16 bits, what they're saying is we're sending 2 letters of the alphabet, or 2 numeric characters, or whatever you want to call it, or any special characters, which are comprised of these electrons. Okay? So you have it wouldn't be 8 electrons, it would just simply be a group of electrons representing 8. Well, it'd be representing the number 8, or basically, you know, not really specifically the number 8, but the 8 bits. Okay, so these electrons represent the 8 bits. So there would be 8 bits on one lane, 8 bits on another lane, which would represent 2 different letters. They'd be on the highway in 2 separate lanes. They go straight on, and they go at 33 megahertz a second. All right. Now, when the PCI bus came around, now you had 4 lanes instead of 2, okay? And so now 4 characters were sent off at the exact same time, and they were going at 33 megahertz, okay? And what happened was that it went from 4 lanes to 8 lanes. That's where you get that 64-bit. And now 8 characters are traveling down the road at exactly the same speed, okay? Alright. Now, it is true that the faster these data packets are sent from the PCI bus to the CPU, the faster the computer processes the information. Eventually, the PCI bus was replaced by something called PCI Express. But then, but before that happened, okay, before PCI Express came around, there was also the low pin count. And then after the PCI Express came out, then you had another thing called the USB. And I will go through both of those in a future video. Okay? So basically what's happening here is that the speed of the letters going from the peripheral to the actual CPU was increasing, but also there was more lanes, so more letters were traveling in a data packet at the exact same time. And there you go, and that's why they created those PCI buses. Alright, now if you want to know more about these PCI buses, I have a hyperlink down here, and if you want to leave me feedback and you want to correct anything in this video, let me know, and then the next video I will go ahead and put those corrections in there. Alright, I want to thank you very much for watching this particular video. I will tell you more in a future video, so I'd like for you to stay tuned.